Hello folks, and welcome to this revision lecture of Paths, Routes and Networks. If you have not watched the previous revision lectures or have not attempted the quiz of this topic or other topics, I would recommend doing that first and then coming back to this lecture. If not, you can keep watching if you're watching the recording. Pause the recording, try to attempt the set with us, and then watch the solution immediately. Alright folks, let's begin with set number 1. Ravi plans to visit 6 cities, A through F, starting from city A, and he knows the distance of all existing routes connecting these cities. The following table gives the distance in kilometers of the route connecting any two cities. Okay. Any cell in the table that is shaded indicates no route exists between the two cities corresponding to that cell. Okay. So guys, whenever we have talked about path, route and network, one thing which I've always told you to take care of is being aware if a specific road or route which is connecting two places is unidirectional or bidirectional. Correct? So, although this looks fairly like a symmetrical table, but I will still quickly check if every 12 and 12, 11 and 11, every number has its counterpart or not. Just in case they have set up a trap of making one or two roads unidirectional, which is not the condition in this case. Okay, but it's always a good check to have. Now, one way, of course, in this set is that you can move forward with the questions with this table itself, which is absolutely fine if you'd like to do that way. Another way is to convert this table into a diagram, which we are more familiar and comfortable with. And I believe that would just help you do this set and its questions much faster. Right? So let's say I start with point number A. Now I know A is connected with three places, B, C and E. Okay. So let's say A is connected with B, C and E. Okay. Now how about B? B is connected with C and F. So B is connected with C and B is connected with F. Okay. How about C? C is connected with A and B, which is already done, and with D and F. So there is a connection with F and there is a connection with D. How about D? D is with E and F and with C as well. So then E and F and C as well, right? And I can see that E and F are also connected. So this is a rough diagram which I was making in order to show how to convert this table into a diagram. And you can just quickly mark the distances, like I know A and C is 11, A and B is 12, so on and so forth. Right? And then you can use this diagram to visualize the whole thing better and answer the questions faster. Alright, let's look at the questions. So this is the diagram which will come out if you adjust it properly. Okay. Question number 1. If Ravi starts from city A and plans to visit city F, but plans to visit city B before visiting city F. Okay. What is the minimum distance that he must travel? Okay. So that means Ravi has to go through B and is starting at A, ending at F. Okay. One way, of course, is directly going from A to B to F, which is giving us 23. But I would also like to check if other options are possible. Yes. So also guys, since we are looking at minimum distance, in more often than not cases, as I increase the number of stops or number of cities, the distance will only increase. So ABF had 0 other cities apart from the source, the mandatory stop and the destination. Whereas if I add another city, we will have one more city. Distance may go up or down. But I know for a fact that if I add 2 or more cities, the distance will definitely go more than 23. So here I'll just take one more case where I can see that city C, which is there, could also be considered. And if I look at this route A, B, C and F, the distance is 22, which is less than 23, and therefore this is my answer. Okay. Question number 2. If Ravi plans a route such that starts from city A and visit all the cities exactly once and finally returns to A, what is the minimum distance that he must travel? Okay. Now this might look like a rather overwhelming question, but it's pretty straightforward if you know how to go into this. Okay, we know that Ravi is starting from city A and coming back to city A, right? So the way to find minimum distance, again this is empirical, not a rule, right, is you see and start with the minimum distance from every point. Like from A, I can see AE is the minimum distance of 8. So I can maybe start with going from A to E. Okay. Alright. Now once I'm at E, I know I cannot go back to A. No other city is visited more than once. So from E, I can see the minimum distance is 9 going to D. Right. Then going to C. Then going to F. Then going to B. And finally going back to A. This way I am able to choose minimum distance at every point and also ensure that I'm not visiting any city more than once. And this route I think will give you the answer, which is 58. So that's it for question number 2. Okay. Let's look at question number 3. In how many ways can Ravi travel from city B to city E such that he visits city A exactly once but does not visit any city twice? Okay. So we have to go from B to city E, right? And we have to visit city A for sure. Now again, many ways to do this, but one way that I really like to do is you can reverse engineer the whole thing. Alright. Since I know that I have to reach city E and there are 3 roads reaching city E. One is AE, one is DE and one is FE. So I will make 3 such categories and then I will start reverse engineering from there. And once I do this, it will be a very exhaustive approach and I will get my answer to be 8. You can go manual counting, not an issue, but there is an off chance that you might miss 1 or 2 counts, right? So the answer to question number 3 is 8. Very straightforward counting question. The only thing that you need to take care of is that you don't miss a case. Alright. Question number 4. If Ravi always takes the shortest possible route when traveling between any 2 cities, then between which of the following pairs of cities will Ravi have to travel the least distance? Okay. So C and E, if I have to look at the shortest route between C and E, I can see it's 19, right? CAE, it's 19. Between A and D, I see it's 17. AED is 17, right? Between B and D, I see it's 18. And between B and E, definitely more than 17. So that's it. That's my answer, AD. So, as I was saying, you could have done it directly from the table which was given to us originally in the question, or you could have converted it to this diagram. In my opinion, this diagram makes it slightly easier and slightly faster to solve this complete set. Since all the questions had made you make more cases with each question, so there was no direct question here that we could just plug in the answer from, right? Alright, so let's move to set number 2. This I think is one of the more interesting sets of this test. Let's do it together. 3 buses B123, 345 and 456 travel between 6 different stops A through F. These stops are connected by the roads indicated in the figure below. Each of the 3 buses travels indefinitely along a different route among the 3 routes. The 3 routes have been given to us. Not necessarily in the same order. This is the first point where it starts getting complicated. So I don't even know which bus follows which route. I will have to figure that out to even begin understanding this question, right? Further, any bus while traveling from one stop to the next does not pass through any other stop. Okay. The fare of each bus between any 2 stops is calculated as product of the distance between the 2 stops and a per kilometer fare which is distinct for the 3 buses. Okay. The distance in kilometers between any 2 stops is a natural number and the per kilometer fare is a natural number greater than 2. So greater than 2 is given. This is key. Please don't forget it's 3 or more. It's not greater than equal to 2. Okay. On a particular day, 10 persons traveled in 3 buses. The table below provides for each of the 10 persons and the bus that he traveled on The stop where he boarded and the bus, and the stop where he got off the bus, and the fare paid by him. Okay. It is known that no person traveled through the same stop twice. Okay. So guys, clearly this is a longer set. I need to first understand which bus follows which route. Then maybe I'll be able to figure out the per kilometer fare for each bus. And from that, I would most likely get the distances between the stops. And then I would be able to answer the questions. So reading this, I know where I have to go, but it's clearly a longer route. So I'm not sure if this would have been the best set to choose among the initial sets in the exam setting. Okay, let's start. So I have the 3 routes. Let's figure out if we can get the buses, which bus is on which route. Okay. Alright, let's first look at B123. Now, if I look at B123, there is Ram going from A to D and is paying 42. Then there is Uday going from B to E and is paying 54. And then there is Jay going from B to D and is paying 36. Okay. And that's it. That's all I know about B123. Guys, do you observe something? If I look at these 2 people, they both traveled from B but went to different destinations E and D on their specific route, right? And this person who went to D paid less than this person who went to E. That means in my route, B to D should be less than B to E. Correct? Let's see which of these routes satisfy this, because that is, I think, the most easiest way to actually find the combinations. So in route number 1, yes, B to D is shorter than B to E, so this could be 1, 2, 3. In route number 2, B to E is shorter, so this cannot be B1, 2, 3. And again in route number 3, B to E is shorter, so this can also not be B1, 2, 3. So clearly I know this is the route where B1, 2, 3 is operating. Is it clear with everybody? Yes? You could have also done it the other way, right? Like D is the common destination and A and B. So A has to be further than B. Even that was another method. Same logic though. Okay. Let's figure out the other 2 routes. Let's look at 4, 5, 6. So 4, 5, 6, I can see D to F 32. C to E is 24. C to A is 12. And D to A is 28. So clearly C and A and C and E. So A has to be closer to C than E, right? But that I see is the case in both the routes. So that is not the way to go. How about D and F, D and A? So DA has to be closer than DF. Yes. And that is the case only in route number 2. DA is closer to DF compared to route number 3 where F is closer to D than A. So therefore I know this is the route B4, 5, 6 and this leaves B3, 4, 5 for this one. Is this clear? I think step number 1 is pretty straightforward, but yes, definitely time taking. I'm not saying it's easy. Next we need to find out the rates. Okay. Alright, let's see. Now guys, what is the most logical way to go about rates? LCM, right? Because if I know multiple people have traveled on the same bus and have had different fares, the only constant there, because it was a product of distance and the per kilometer fare. So I will find the per kilometer fare by using LCM. Okay. So if I look at 1, 2, 3, the bus route 1, 2, 3, the fares are 42, 54, 36. 42, 54, 36. So, and I know the fare is greater than 2. So it can be 3 or 6. I mean the LCM, HCF. HCF is 3 or 6. HCF is 6, but it can also be 3, right? Don't forget that. Don't assume it's 6. It may or may not turn out to be, but do not assume. How about 456? I have a 32, I have a 24, and I have a 63. Not 63. I have a 12 and 28. Sorry. So I have 24, 12, 28, and 32. Only possibility for HCF over here is 4. Right? And how about 3, 4, 5? I have a 90, I have a 36, I have a 63. So again, it can be a 3 or a 9. Right? So 4, 5, 6 is the only route for which I can for sure understand that 4 is the per kilometer rate. Guys, also remember, it was told that the rates are distinct. So if I can understand what is the rate for 1, 2, 3, if it turns out to be 3, then I will get 9 for the other route, and vice versa 3 and 6. But if it's 6 and 9, we'll of course have to work for our meal. Okay. Alright. Now that I have the bus routes connection and the rate for 4, 5, 6, let's try to find the distances. Okay. Alright. Since the only rate I have is for 4, 5, 6, I will start with that. Now 4, 5, 6, the first percentage is going from D to F. So D to F, the way to go is D to C plus C to B plus B to A plus A to F. Correct? 4, 5, 6, D to C, C to B, B to A to F. And this is given to us that he paid a total of 32. And if the per kilometer rate is 4, that means these distances are total of 8. Correct? Okay. What next? Then I have Sudeep going from C to E. C to E. That means CB plus BA plus AF plus FE. Correct? And that is given to me as 24. So this becomes 6. Okay. Then I have Parvesh going from C to A. So that's nothing but CB plus BA. Right? And that is equal to 3. Okay. And last I have D to A, which is nothing but DC plus CB plus BA. And this is nothing but 7. So guys, if I look at these two equations, CB plus BA, I can just subtract and I will get CD equal to 4. This becomes 4. Yes. Amazing. How about if I look at this equation and this equation? So again, DC, CB and BA becomes common. So AF equals to 1. This becomes 1. Correct? Amazing. What else can I do? Now, here I know AF as 1. I know CB plus BA as 3. So I can get FE equal to 2. Yes. Okay. Okay. Now guys, I have the distances for 3 routes. I can use these distances in other routes that we have been given for B1, 2, 3 and B3, 4, 5. Right? From there we will get the per kilometer fare rate for each of those routes. And from that we'll have to derive all the other distances. So it's definitely a lengthy set. I think one of the toughest sets of this test. But also it's not lengthy because it's confusing, or it's not lengthy because it's complex. It's just lengthy because it's a longer process, right? So if anybody who is stuck in a set where they're not able to make deductions, right, or are not able to make sense of clues, then at least putting time in such a set where you know you will get the result. It's effort, but you will get the result. So always remember, bird in hand is better than 2 in the bush. Alright. So once we complete this process, we will get all the rates and all the distances. I hope the process is clear to everybody. Yes? Alright. Let's answer the questions quickly. Who among the following would have passed through the maximum number of stops? So I need to take each route and which bus they went into, each person, which bus they went into, what was the route, and just count the number of stops. A pretty, again, a manual laborious kind of a question. No smart tricks. So it will be Tej. Okay. Question number 2. What is the minimum distance that any bus will travel when going from D to A? Now here, what is my first task? I will see minimum stops, or what is the routes rather. On 1, 2, 3, I have D, E, E, F, F, A. So D, E, E, F, F, A gives me a 6. Okay. How about the second one? D, C, C, B, B, A. D, C, C, B, B, A. 7. And last one, D, C, C, F, F, A. D, C, C, F, F, A. Again a 7. So clearly it's bus 1, 2, 3 going at a distance of 6. Right? Question number 3. If a person travels from D to F on 1, 2, 3, what is the fare? On 1, 2, 3, D to F is nothing but D, E and E, F, which is 5 into 6. So that's 30. I think the last 3 questions are pretty straightforward. You just have to look at the route and add the distance and multiply the rate. That's it. Correct? So, not very difficult from a question standpoint, but definitely difficult from getting all the values and a lot of time investment. Okay. So here's another lesson which I think you should take away from this type of a set is this set might have 5 questions which might look very lucrative compared to any other 4 question set. But I believe that in the time that you would have done this 5 question set, you most likely would have been able to do another 2 4 question sets given the length of this set, right? Okay, so always prioritize your ROI and not just the number of questions in a set. Okay, let's move to set number 3. This I believe was the easiest set of the test. Almost a sitter, right? Let's do it very quickly. A courier company represented by A in the diagram below has exactly 2 motorists who travel to various locations in the city to deliver packages. Okay. In the diagram, B through I represent the locations at which packages were delivered on a certain day. Arrows represent the routes along with the directions that the motorists took that day while traveling between locations. The motorists did not travel along the same route, but each route was taken by at least one motorist on that day. Okay. Each motorist stopped at every location that he came across on that day, and at least one package was delivered by each motorist at every location that he stopped. Further, the motorists returned to the company after they delivered all the packages that they carried. So clearly, this is of course in a path route network quiz, but one thing that we understand from paragraph number 2 is the final inflow from I and G will be 0. So the sum of packages in the whole circuit will be the total output, which is 21 in this case. Something to really remember. Okay. The numbers given in the circles are at some of the locations represent the number of packages delivered at the respective locations by the motorist that visited that location. The numbers mentioned alongside some of the arrows represent the packages carried by the motorist who traveled along the respective routes. Okay. So let's figure out as many numbers in the circles and on the arrows as we can. And then let's see. Yes. All right. So I know the total outflow from A is 21. I don't know what number of packages were delivered at B. Let's call them X. Okay. So this will be 11 minus X. Right. And at C they delivered 4 packages. And the outflow was 8. Correct. So what will be the outflow on the line CD? It will be nothing but 11 minus X plus 10 minus 4, which is the packages at C, minus 8, which is the number of packages carried on the CE route. So this is 21 minus 12, which is nothing but 9 minus X. Okay. Okay. What else can I say next? Okay. one thing which I can clearly see is that 8 is coming in here and 7 is coming in here and 13 is going out here. So this has to be 2. Correct? Okay. What else can I do? Since I know 8 directly went from C to E and 7 came out here, there would be some packages delivered here from 9 minus x, and therefore we got 7. Guys, we also know that minimum package at every stop is 1. So if let's say at D there is only 1, right? So if you think about it, x I know as a number has to be greater than 0, and D has to have minimum 1 packages which are delivered to the destination D, which clearly tells me this is only possible when x equal to 1. Yes, that's the only possibility for this. So therefore I know this is 1, 10 packages went here, right? 8 came out over here, 1 was delivered here, 2 were delivered here, and from 7 I know minimum 1 were delivered at each of these places. From E to F 13 were carried, right? And 7 were delivered at F. So if this is Y, this becomes 6 minus Y, and rest of it I don't know. Okay, that's all this is. That's all the information we can deduce. Let's look at the questions. How many packages were delivered at D? Clearly 1. At which location maximum number of packages were delivered? Clearly F, because I know that the packages going out of F are 6. So IGH cannot be more than 7, and rest of the locations like B, C, D and E are already less than 7. So I know for sure that F has to be the maximum. What is the total number of packages carried by the motorists who traveled between C and D? It's 8. And what is the maximum number of packages that could have been delivered at H? So total 6 have gone out of F. If I want to maximize H, I will minimize I and G. Minimum they can be 1 each. So H can be maximum 4, and that's it. The set is over. I think this set was very easily doable within 5 minutes. Understanding, deducing values and answering the questions. Questions again were very, very straightforward. So guys, this is what I was referring to. That if I do this one kind of a set and another 4 question set, I will definitely get more marks than doing the 5 question set that we did at position number 2. Right? Let's look at the next set. Okay, this is another interesting one. So in a city, 6 places A through F are connected by a certain number of two-way roads. Okay. The number given alongside each represent time taken in minutes for any person to travel along the entire distance of that road. Okay. Guys, always remember this, right? If the numbers on the arrows are minutes or kilometers and whatever, don't mess up the units of measurement, because sometimes they just might add an element of speed and ask you the other thing like time or distance. So don't get confused. Okay. 2 traveling salesmen, Aram and Vishram, travel between the 6 places, and both of them know the time it takes to travel along each road. Okay. Further, Aram can travel for at most 15 minutes at a stretch, after which he will get exhausted and has to stop for a cup of tea. Okay. After having a cup of tea, Aram can travel for at most another 15 minutes and the process repeats. Similarly for Vishram, it's the 20-minute thing. Okay. Alright. Since they can find tea only at the 6 places A through F, the 2 salesmen plan any trip keeping in mind that they have to stop for a cup of tea in one of these 6 places before they get exhausted. Guys, it's the same thing. A car and a petrol and what is the mileage and what is the distance it can travel. The same thing given in a different format, nothing else. Okay. Just before starting any trip, each of the 2 person will have a cup of tea at the origin. Further, each person tries to minimize the time he takes to reach the destination from his origin. Okay. So guys, before I even get into this set, what are going to be the 3 categories of distances which will essentially determine where my differences will come into play? any distance which is less than 16, any distance which is more than 20, and any distance in between. So these are the three categories which will tell me whether they will stop, they will go through the same route, they will change the different route, so on and so forth. So all I have to keep in mind while looking at this diagram going forward is if the distance is in which of these categories. Okay, that's it. In the figure given below, the places represented by the circle shaded with vertical lines have a 10-minute break and a horizontal line has 5-minute break. Okay. When stopping for a cup of tea, they don't waste any other time. That's all that is given to us. So all of this, long RC, we can summarize in 4 lines. Aram can travel 15 minutes, Vishram travels 20 minutes, vertical lines is 10 minutes, horizontal lines is 5 minutes. That's it. Okay. Let's go to the questions because there's nothing really to deduce in this set, right? Each of Aram and Vishram start from D, okay, at the same time and wanted to go to B, okay. What is the difference in the time taken in minutes by Aram and Vishram to reach B? Okay. Now D to B, I have a lot of routes. D to A to B, D to C to A to B, D to F to B, and D to F to E to B. Correct? Guys, will I check all the routes for both of them? Will I check all the routes for both of them? And the answer would be no. I will not check all the routes for both of them. I will see which routes are falling under which categories that we had discussed. Correct? For example, this is exactly 15. So for the route AD, both of them will go the same time. And there is no route connected from A which is less than equal to 5. So if they go along this route, I know both of them will start at D, go to A and take a break there before moving forward. Correct? Similarly, if I look at D to F, I have 14 minutes, right? Now from 14 minutes, I'm left with 6 minutes for Vishram. Is there any route from F which is giving 6 minutes? No. So again, I know that all of these distances where the distance is either less than equal to 15 or more than 20, it's the same thing, right? With that in mind, we will figure out a few minimizing times, right? So for example, if I look at DFB, for here, both of them will take the same time. F is vertical lines, so that is 10 minutes, right? So total becomes 33 minutes for both of them on this DFB route. Okay. Another way which I will think, so I'm just sort of telling you how to think. This question is easy, right? It's not this lengthy. Another way that you should think is, if I have to minimize the time or if I have to take extremes, I will try to stop at a horizontal circle than a vertical circle. Correct? That will also be an element in this. Alright. So guys, if you look at this, if Vishram goes along DCAB, right? CAB falls in that middle category. The distance CAB falls in that middle category of being more than 15 but less than 20. So Vishram has a choice of taking a stop at C, which is minimum for the break. So Vishram can go 9 minutes, then 5 minutes, and then 16 minutes. So total 30 minutes. Whereas, of course, this luxury is not there with Aram. And therefore, the difference in time will be 3 minutes. Are you clear how to think on such questions? You don't actually have to make all the routes and all the possibilities and really compare. That's a waste of time. Be smart. Be deductive. Okay? Oh, why am I erasing this? We can just go to the next page. Sorry. Alright. If Vishram starts from C and wants to go to E. Wants to go to F. Okay, wants to go to F. How much time will it take him in minutes? Okay. Batao. we have been given Vishram specifically. Okay. If it were the same, one and the same, it would not have mattered. But if I know Vishram has been given, that means there is a route where I have to look at a distance in terms of time, which is more than 15, less than 20, where Vishram can take advantage of it. So clearly, I already figured this out, that CAB is that route where I am taking 16 minutes. Then again, B is very conveniently a horizontal circle, so 5 minutes there. And 9 minutes from B to F, which will give me a total of 30 minutes. And that's my answer. Simple. Question number 3. Each of Aram and Vishram started from A. Okay. And wanted to reach one of the other 5 places, say X. If each of them took the same time. Guys, what does this mean? That they are only following routes which are either both less than 15, less than equal to 15 or greater than 20. Right? There is no route which is involved, which is in the middle. Only then they can take the same time. Right? So can I reach F? No, because it's 19 minutes, which is in the middle. Okay. Of course, for B, for C and for D, it will be the same. F is out of the picture because we have also been told that their primary motive is always to minimize the time. So they will not go a longer route just for the sake of the question. Okay. How about E? Again, if I go A to B to E, the timing is between 16 to 20. So even E is not possible. The answer is 3. Clear? Very straightforward. Alright, question number 4. If each of Aram and Vishram started from C, okay, and wanted to reach one of the other 5 places, say X, if each of them stopped the same number of times, now we are not being told about time, we have been told about number of stops. Okay. A, of course, A and D, they will take 0 stops, right? How about B? B will not be the same for both of them because it's between the 16 and 19 mark. Yes. How about F? F is above 20, right? So then that will be same for both of them. And again, E will not be. So the answer is 3 for this question as well. So guys, I hope you're able to understand how we can do this without really calculating all the routes and all the distances and times and so on and so forth. Not required. Be smart, understand what are the bottlenecks in these types of sets, right? And I think this 5-10 minute bottleneck and understanding that any time between this range, these are the 2 things which are going to affect the complete set. There is nothing else. Okay? Alright. Let's look at the last set. Clearly a very lengthy looking set. Right? But let's see what's the logic, and let's see if we can get a few low hanging fruits quickly on this. Right? The network diagram shows all the dams across the rivers along with their relative positions. It also shows the interconnectivity of the dams for the transfer of excess water between them. Okay. While the inflows into the dam from other sources are not shown in the diagram. Okay. Further, there is no outflow from any of the dams except the excess water, if any, that is released. Okay. The following table shows the water inflows into the dam from other sources, not including the inflow from upstream dams during each week. Okay. So here we have only the inflow outflow between the dams, which is excess, and here we have inflow from only the other sources, right? And of course the last table is giving us the situation at the end of January and the overall capacity of each dam. Okay. What is the note telling us? That A through G are the names of the dams, and the arrow marks in the network diagram indicate the downstream direction, which is the direction of flow excess water between the dams. Okay. And each dam can choose to retain water up to its full capacity or any part thereof, and water in excess of this retained capacity is released equally to all the dams that are immediately adjacent downstream to that dam. Okay. I think this point number 2 is important, that if from A there is any release which is happening, it will go to equally B and C. It will not check their capacities and what excess capacity they have or not. It will be equally distributed, right? And of course, the whole network's outflow is going into the sea. Okay? Straightforward. Let's look at question number 1. If except dam G, which retained water to its full capacity, okay, so dam G is operating at full capacity, all the other dams retain water only 50% of the respective capacity. So like 750 for this, 400 for this, 375 for this, and so on and so forth. Okay. Then how much water flowed into the sea during the first week of February? Tell me guys, what is a smart way of doing this? One, of course, is that, this is the situation, this was the situation, this was the inflow, and there was no outflow, right? So whichever dams had overflows, we mark those, right? And then if they are in the same network, we just add the overflows, and that's the simple way to do this, correct? A, there is no outflow. We have just been told to look at first week of February. Okay. How about dam B? So 400, 300 was already there, 150 came in. So there was a 50 overflow at dam B, which clearly went to dam E. Now dam E, if I look at, capacity was 300, right? 300, 120 was already there, 150 came in, making it 270, and 50 came from B. So there is 20 going here. Okay. All right. That is from B. There will be additional, there may be additional from C and D. We don't know yet. Okay. How about C? C went down to 375, 250 was already there, and 120 came in additionally. So again, there was nothing at C, nothing from C, nothing from A. And that's it. I just keep repeating this and I will get my answer. Yes, I think the final answer will come out to be 90 if I'm not wrong. Clear guys? So you may or may not have gotten to this set, but this would have been one of the easier questions to do. Not the easiest, but yeah, I will explain what that means as we go forward in the questions. Okay. But is this clear? Yes? Alright. Let's move to question number 2. This question number 2 is sort of a classic example of the kind of questions you should leave in a set, just keeping in mind the ROI, right? Of course, if this is one of the last sets that you have picked up, and if you have done the other 4 questions of this set and you have left time, then you could do this question. Otherwise, this was a lot of additional calculation for no real ROI on your marks, right? Let's look at the question. Dam A, B, C, D are located in state P. Okay, so this gets cut here. This is state P, this is state Q. Okay. If at the end of January 2020 the capacities of A, B, C, D were increased by this. Okay. So I have to essentially revise all of these 4 numbers that I have over here. Okay. And these dams then retained water up to their respective full capacities. Okay. So I have to take this sum, add with this, see if the increased capacity is giving any sort of overflow or not, and do the same for all of them, right? Then what was the resultant decrease in the volume of water that flowed into state Q during February? So that means I need to calculate the before, what was the flow, and the after, what was the flow, and then subtract that. And for after flow, as I already discussed, we have to calculate the revised full capacities. So it's a lot of work. I don't recommend doing this type of a question in an exam setting if you have something better to do. If not, be my guest. You already know the set, you already know the constraints. If you're good with math, right, doing it quickly, go ahead and do it. Alright, just for the sake of completeness, the answer to this question I think is around 410, right? But Just to repeat myself, not a question worth doing in an exam setting. Right? Guys, we have discussed this over and over again in previous discussions as well. Just because you're doing a set does not mean you have to do all the questions. And just because you're not doing a set does not mean you can't do any of those questions. Right? The goal is essentially to get marks wherever you can get them from and how much ever you can get them. Okay? Question number 3. If at the end of January, provision was made for excess water from dam B to flow into dam C. So there was a pipe made over here. Okay. Then what is the resultant volume of water that can be saved from flowing into the sea during February? Assume that all the dams retain water up to their full capacities. I love this question in this set. Because if you've actually understood the whole flow and you've read the table, you don't even need to solve this question. Why am I saying that? Number 1, because 1, they're talking about the complete month. Okay? If you quickly glance through the numbers, you'll find all the 6 dams are overflowing in the whole month considered, with their capacity and with the amount of water they had at the end of January. Which means that it doesn't matter if you route the water from here to here or here to here or here to here, doesn't matter. If the final outlet is C, it will remain the same. So the change in this will be 0. This was a low-hanging fruit where you are not really expected to do calculations. And these are the kind of questions which I urge you take up, you identify, and you get your marks quicker than the question that we discussed in question number, this set itself, question number 2. Right? Think, because this is the kind of logical deductions which are expected to you in an exam setting in order to maximize your marks. And these small deductions are the ones which will really help you boost your percentile at the end of the day. Okay? Let's look at question number 4. Again, a very similar sitter low-hanging fruit. If all the dams retained water up to their respective full capacities, then from which of the following dams was the maximum volume of excess water released during February? Guys, do I need to solve this question? If you see, the complete network's cumulation is happening into one single dam, from where the release is happening into the sea. So I don't really care about what is happening in the network. If they're just asking me what is the maximum volume of excess water released from a specific dam, it will be G. I don't need to solve this question. Because whatever is the excess in the network, that will eventually come to a G and overflow from that. The only thing, if at all, again does not really apply, is if G's capacity would be something really big, then it would be a different thing. But since G's capacity is smallest in the network, this is a no-brainer question. Understood? And I think it's very smartly crafted, because if G's capacity was, let's say, 10,000 units, just hypothetically, then of course I would have had to go back to the network and understand where the maximum flow is happening. But that was not the intention of this question. It was to check your presence of mind and logical deduction. Okay? Let's look at the last question of this set and this test. If all the dams retained water up to their respective full capacities, then between which pair of dams was the maximum amount of excess water exchanged? Again, guys, do I need to really calculate? No, I don't. Because I know that the final 2 routes which are towards the end of the network are EG and FG. So one of these routes has to have the maximum. Of course, the overall maximum will be G to C. The C, not the C, right? But within the network, it will be between EG or FG. Okay. You might want to calculate that. But again, is there a smarter way? Definitely there is a smarter way. What is the smarter way? So clearly I will just remove the B and E option and C and F option. Okay. All right. Now here for the time being, I'm sort of ignoring the numbers. To be completely sure, you have to solve this, right? But if I had to take an educated guess, this is how I would have taken this, okay? Now, whatever would be excess of A, half the excess of A would go to B, half A, and half A over here. From here, complete half A and B will go to E, okay? Okay. Here, I will have half C going and half C going here, and 0.25A and 0.25A going here. This is a mental exercise. I'm just showing it so that you understand what I'm doing, okay? Here I will have complete of D and this part. And if you look at F to G is just half C, 0.25A and F. That's it. Whereas E to G, it's 0.5A, B, D, and all of this. So the only case which I have to check, if I have to check at all, is if the flow of only F greater than B, D and half A. Because if you see, this element and this element cancels out. So if I had to take an educated guess, I would have just directly marked E and G. If I had to be doubly sure, I would just check F against 1, 2 and 3. And again, this question could have been done smartly without really doing the calculations. Is it clear? So this set, as daunting as it might look, and yes, the first two questions, especially the second one, was a lot of time taking. But yeah, the other three questions were absolute sitters, and you could have grabbed those bonus marks as quickly as you should. So that's it. That brings us to the end of this revision of path route network, and I will see you guys in the next lecture.